This is the big review for tomorrow's test. It starts off with number 1, which is going to be on every single test because I need you to understand this idea. It asks how many planes can be drawn through any 3 non-collinear points. And so if you look here, I have 3 non-collinear points, right? Anytime you draw 3 points, you have sort of a triangle there, as long as they're not collinear, right? They don't exist. You can't draw a line through all 3. Well, if you can't draw a line through all 3, you can't really draw more than one plane through all 3, right? You can't have another plane that sticks out, comes towards you, or goes away from you, or goes off at some sort of weird angle through 3 non-collinear points, and I needed you to understand that. So I feel that that's one of the biggest ideas that you need to understand, and so you can only draw 3 non-collinear points, and I gotta bring this up so I can. With any 3 non-collinear points, you can only get 1 plane, okay? And I'm glad we understand that. And non-collinear means they don't exist on the same line. Collinear, of course, means they exist on the same line. Now we're going to talk about which 3 points in the figure are collinear, right? So we look at A, C, G is underneath there, so it's not on the same line. A, B, and E is sort of out of the way. It doesn't really fit with any of these other 3. So really the only line that we have here that has 3 collinear points is this one here, this FEG. And don't be thrown off by this figure. B and E would send a line. If I show you a line, let's see if I can show you a line that cuts through it. If I do this just right, yeah. So that line would go way out here, so A is not a part of it. Okay, so I'll get rid of that. All right, so we see that FEG is the only one that has, oh, sorry, I'm not supposed to be in that. I'm supposed to be back doing this. There we go. FEG is the only one. Now, name the intersection of plane P and the plane that contains points B and C. And this is where I made my mistake earlier. But I think I'm going to be okay with this. Name the intersection of the plane P, that's this gray quadrilateral here, and we have BC right here, right? So what plane? Well, we say we can name the plane is BCD, and I made a mistake when I first started talking about this, saying that that's the plane that intersects it, but it just says name the intersection of the plane, and that would just be that line of BC. So I may give it away if that's if that's something there, or I may say name the plane that intersects plane P. Okay, so that would be BCD, but in this question itself, it's BC that intersects this line here that continues on and on, intersects this plane, of course, because this plane is infinite in all directions. So I'll go ahead and move on. Let's get rid of that. Come back here. Find the length of RS. I did talk about this in class, so we know that RS goes all out here, and our inch is cut into 16ths, just like almost any ruler that you see. So we know that here's a half, here's a quarter, and that quarter is cut into quarters, so we're talking about 16ths. And so we count the 16ths from here, 1, 2, 3, 4, 5. So our answer would be F 1 and 5/16. Really pretty easy. And then the next one, we actually have to draw the figure. Okay, so here we go. I'm going to draw a line. Here's a line. And then I'm going to start naming these points, okay? Given that A is in between, somewhere in between, this is A, and it's somewhere in between Y and Z, all right, so we have Y and we have A in between Y and Z, and it says that YA is 5.5. It doesn't give you any units. You don't have to worry about units on this one, and it says that AZ is equal to 2x. There's 2x. And it says that the total length, I'm going to do this in a different color so you can see it a little bit clearer. The total length here, right, is 41 and 5/10. Excuse me. And then it says find the length of AZ. It doesn't say find X, it says find the length of AZ. If a test says find X, then we can find X, but this one says find AZ, and that's our big goal, right? So find AZ, be able to read the problem and find what you're looking for. So I'm looking for 2x. I'm looking for what this value is going to be. Well, what do I have to do? I have to solve for x first. So let's go ahead and write out that equation. 2x, which is what we're looking for, plus 5.5 is equal to 41.5. Great. So we solve this like we would solve any equation. So we go ahead and we subtract the 5.5. Subtract 5.5 here. And then this goes away, and what we have is 2x, and bells should be going off right now, in your head that is 36. Now, if you realize that 2x is equal to AZ, stop right there, because you found it. If 2x is AZ and 2x is 36, then AZ has to be 36. This is a big skill in geometry. You know, if this is this, then this is that, right? If this is this and this is this, right? So if AZ is 2x and 2x is 36, then AZ has to be 36. So, of course, you could stop right there. If indeed you didn't get there, that wasn't part of your plan, okay? And you wanted to go ahead and continue to solve, go ahead, continue to solve. But the problem here is don't fall into the trap of saying, hey, Mr. Sokol, I found that x equals 18, and now I'm going to be done and I'm going to circle 18. 18 is not the answer, right? We know that AZ is 2 18s, so we plug our 18 into 2x. AZ is 36, right? Don't forget, AZ is 2x. It says it right here. AZ is 2x. And if you found x, then just multiply it by 2 and you have your 36. So it was a long explanation for something that you could have already found. Okay, this says, and I like this visualization that they have here, find the length of PQ. PQ is this space right here. It's that empty space, and all we had to do is take our 38 and 3/10 centimeters and subtract from it 12 and 6/10 centimeters. Well, I guess it's just trying to use that skill to do some regrouping. I guess you could regroup if you felt like it. You say this is a 7, you borrowed a full set of tenths, and now you have 7, and then 5, and 2, right? Could we have estimated this? I believe I mentioned this in class. Yeah, you absolutely could have estimated this, and you could have gotten rid of these first two answers, right? Because they're way too large. This first answer is if you go ahead and add these two things together, you would get that 50.9 centimeters. But that's too big because PQ is shorter than the whole, than PR. 46.3, I don't know where they came up with this answer, but we know that that's larger than 38.3 centimeters, so we're going to get rid of that one too. So even if you didn't know how to subtract, I forgot to put the unit in there, we could have taken a guess here, right? You had a chance between 25 and 7/10, which is our answer, and 21 and 3/10, and just by looking at this, even if you just said 38 minus 12 is 26, you could have said this is really close to that 26. I'm going to move on because we have a long way to go. Find the value of y. Now we're looking for y. We're not looking for the length of a segment. We're looking for the value of that variable. Find the value of y if b is between a and c, and AB is 2y, and BC is 6y, and AC is 48. So let's go ahead and draw it. There we go. Let's make another one just to show that AC is 48. It's just about the same. And we'll go back to that color, and we're going to start to label. As soon as I get rid of that, this is, I'll put it here up above, A. I'll put a dot here. We'll call this B, and then we'll call this C. Is it to scale? No, it's not to scale, but that's the way it goes. This total is 48, and then we have two expressions, 2y and 6y. All right, and if I add these two together, they have to equal 48. I don't know how many times we've done this particular thing, but it may be a little bit annoying by now. But let's write it out. 2y plus 6y equals 48. My first step is going to be to combine these two things. That's a really simple task for you. 2y's and 6y's are 8y's, and they equal 48. We'll undo this multiplication with division. We'll divide both sides by 8. That just leaves me with y. And 48 divided by 8 is 6. Y equals 6. Is that one of our answers? You bet. That's one of our answers right here. That's letter C. I think the next one is probably the most difficult of the bunch, or second to most difficult of the bunch, because we want to find the distance. And you're going to have this distance formula handy. I don't know why I'm going to be so nice and give it to you. You should already know this distance formula by now. It's x2 minus x1 squared plus y2 minus y1 squared. Okay, and this is just using the ideas of Pythagorean theorem, but we're going to use it in this form. Now, what do I do? Well, first I'm going to label these two coordinates. I'm going to call P coordinate pair 1, I'm going to call Q coordinate pair 2, and I'm going to solve that way. So, the x in 2, which is 5, minus the x in 1 is 2. And I'm sorry I'm not carrying the square root symbol. It gets annoying to keep writing it over and over again. I will shortly. Then the y in 2 minus the y in 1. So the y in 2 is 3 minus the y in 1, which is 8. And then square that difference. Right? So the squares of the differences. And there's my wonderful square root symbol. So bumpy. 5 minus 2 is 3. We can square that. Plus 3 minus 8. Well, I'm at 3. I go back 8 spaces. I'm at negative 5. And I'll square that. And so I'll put the square root symbol in there. All right, so 3 squared is 9. Negative 5 times negative 5, or negative 5 squared, is, 25. We'll put the square root symbol over it. Last but certainly not least, we go ahead and put these together. So 9 plus 25 is 34. This can't be simplified anymore. Once we got to this point, we can look up here and see, hey, is that one of the answers that we have? And that is indeed one of the answers we have. It's right there. Okay, so I think what I'll do is I'll actually use these exact problems, but change the numbers to protect the innocent. Find the coordinates of the midpoint. Oh no, another formula. This is the worst. So I'll write the formula up here for that. So number 9. The formula is x1 plus x2 divided by 2, and that's our x coordinate midpoint, and then we have y1 plus y2 also divided by 2. That's our y coordinate midpoint. Okay, so we're just finding the averages between the points. So what we'll do is we have coordinate. I'm going to write it again just to be sure that you do the same thing on everything. This will be coordinate pair 1, this will be coordinate pair 2, and then I'm going to start to do some work. All right, up here. So x1 is 8 plus x2, which is negative 6, and divide that by 2. And then y1 is 5 plus, sorry about that, y2, which is 2, all divided by 2. And so let's do some easy math. 8 plus negative 6 is 2 divided by 2. That's our x-coordinate. And then 5 plus 2 is 7 divided by 2. I'm not really excited about the fact that they are looking for a decimal answer, but I'll survive it. Okay? 2 divided by 2, of course, is 1. Just by finding this, you already have your answer. You don't have to go any farther. There's only one answer with an x-coordinate of 1. And that's this guy here. We understand that half of 7 is 3.5, and that's what we did. We divided 7 by 2, and we have 3.5. I don't like the way they wrote it, but that's what's on the test. I'm not going to get upset. Let's move on. The volume of a prism with base B is 20 cubic centimeters. Find the area of the base if the height of the prism is 5 centimeters. So let's talk about volume. The volume equals 20 cubic centimeters. And the formula for that is the base, which is length times the width times the height. So this is the base which is big B, right? The base, big B, times the height. Great. If we know this, and we know what the base is, 20 cubic centimeters, the whole thing is 20 cubic centimeters, and we know what the height is, and we just want to find the area of the base, we just want to find what this is by doing this. So I'm going to say big B, the base, times the height equals 20 cubic centimeters. Right? But we know what the base is. We know what the height is. So we're going to go ahead and put that value in there. 20 cubic centimeters equals the base, the area of the base times the height, times, what is that, 5 centimeters. Right? And so B times 5, we're going to undo that with some division. Well, if I do it there, I have to do it here. And this is where the fun starts, right? I know that volume is in cubic units and area should be in square units. Well, if I cancel out one of these centimeters, that does drop it down. All right, 20 divided by 5 is 4, and that 4 square centimeters, and these two things cancel, and that tells me what big B is, and that's what I'm looking for. 4 square centimeters, we have our answer. Moving on. We're getting there, guys. This is super simple as long as you can trace what angle we're looking at. So I'm going to use a lighter color to trace what type of angle is ABC. So I'm going to trace over A, B, and C. There it is. You see it in blue. What type of angle is that? Well, it looks like it's greater than 90 degrees, so I'm going to say it's obtuse. Pretty simple, right? If I gave you a different one, if I said it was CBE or FED, you could say, hey, that's an acute angle. I don't see any right angles here, so I'm not going to put anything on there. ABE, I could say that ray is a straight angle, but I'm not going to use that. So you can rest assured. Use a protractor to measure the angles in the figure. Which segment is an angle bisector? So I'm not going to do that. I'm going to look at these angles, right? I'm going to say most likely because we don't have a protractor handy, right? Not everybody has a protractor. The correct answer to this is GE. GE. I don't like that. ED. No, it's pretty close. I think it should be EG. EF does not cut an angle in half. It looks like this guy right here bisects this angle right here. But what I'm going to say is which two could possibly be an angle bisector. And that would be either GE or ED. So I'm going to give you a choice of two just to see if you can figure out one of the two. Moving on. Sorry, I got to slide this up. And here we are. Okay, this is where the fun really starts, right? This is where it's like double jeopardy. The dollar values have doubled and the scores can really change. Find the measure of FBD and DBE, these two angles here, this angle here and this angle here. Wow, wrong color. This angle here and this angle here. All right, find FBD. We're finding this angle here total. We want this angle here. If these two angles together are complementary, we know that complementary means 90 degrees. You could even visualize it. It looks like 90 degrees. It's telling you that you're looking for something that equals 90. All right, just like before, we've taken quizzes just like this. All right, FBD is twice DBE. So we give DBE an X and we make FBD 2X. So we say 2X, that's the one we're looking for. It's a horrible F, I apologize. Plus DBE equals 90 degrees equals 90 degrees. Now we have our translation, right? We understand the concept. Complementary is 90 degrees. We have both of our expressions. We just simply add these two things together. 2x's plus 1x is 3x, and that equals 90 degrees. Now we undo this by division. We'll divide by 3 and divide by 3. So x equals 30 degrees. Okay. Well, if x equals 30 degrees and FBD is two of them, let's just multiply this by 2. So 2 times 30 equals FBD. And then put the angle symbol in there, sorry. And that means that FBD has to be 60 degrees. Good? All right, let's move on. Which pair of angles are supplementary? Oh my goodness. Now I'm going to have to go in and grab a different color. I used orange on the last one. So I'm going to start looking at these things. I want two angles that give me a straight line. So ABE, that's this angle here. Sorry about that. And CBD. CBD. Nope. They do not. First of all, they add up to way more than 180 degrees, right? They're vertical angles. They're the same measure, but they're both obtuse. Therefore, that couldn't possibly be our answer. Let's look at the next one. A, B, and C, and A, B, and D. A, B, D. Well, A, B, D, if you look at it, is that straight line. So if you put any other angle with it, that can't possibly be it. So we've canceled out 2. I have a feeling that we're going to get pretty darn close soon. ABC, and CBD, CBD. Hey, look at that. If I start at A and end at D, this ray in between, but A to D is, look at that. That's a straight line. This is it. And we'll just check our work just to make sure. ABC and EBD are, again, vertical angles, and they're both acute, so they couldn't possibly add up to 180. Right? But we already found it. Which angle is vertical to ABE? Well, it was in the last question, wasn't it? There we go. And we want this one. Which angle is vertical to ABE? Vertical means they share a vertex, but they're across from each other. So what angle has the same size, because vertical angles are congruent, which angle has the same size and is directly across from it, shares B as a vertex? That would be CBD. And that would be this guy right here. All right, more math. Here we go. If CBF, is 6 plus 18. I don't know why that went away. There we go. If CBF is 6x plus 18, find the value of x so that this is perpendicular to this. What does this perpendicular mean? It means they make a 90-degree angle. I am having trouble writing today, huh? Angle. There it is. So, just simply write and solve an equation. 6x plus 18 equals 90. All right, so we'll subtract 18 minus 18. That goes away. We have 6x equals 72. Divide both by 6. That goes away. 1x equals 12. Okay, and we really are looking for the value of x, right? Value of x. So the answer is J. Good? All right. Last one on this page. Let's just section that off. Section this off because I think we're going to have to do some work. Find ABC if ABC is 4x plus 9 and EBD is 7x minus 9. EBD and ABC are vertical angles, right? We said that they're, let me trace them. I know it's getting messy, but I'm going to try and use a darker color to go over the top. We're looking at these two angles. We're looking at this angle here. And they make an X, right? They make that perfect X. That means they're vertical angles across from each other and they're congruent. So basically what we're doing is we're creating an equation where where these two expressions are equal to each other. 4x plus 9 is the same as 7x minus 9. Okay, well, I need to get all my x's together and all my constants together, all my whole numbers together. So you can do it one of two ways. I always try and get my x's together first, and I always like to subtract from the larger one. This is the larger one. 7 is larger than 4. So I'm going to subtract 4x from both sides. That goes away. Minus 4x. And what we have is 9 is equal to 7 minus 4 is 3x minus 9. Now, I want to get rid of that minus 9, so I'm just going to add 9 to both sides. And what I'm going to end up with is 3x is equal to 18. All right, well, if 3x is equal to 18, all I have to do, I'm going to rewrite it up here so I have space. Oops, let's do it the way it looks because I don't want to mess you up. 18 is equal to 3x. What I'm going to do right now is divide by 3. Divide by 3. And I'm almost there, right? I have x is equal to 6. Now, did it ask for you to find x? No, it says find ABC. I'm still looking for this. ABC is that 4x plus 9. I found that x equals 6. Therefore, ABC is equal to 4 times 6 plus 9. Okay? 4 times 6 is 24 plus 9. So ABC equals 24 plus 9 is 33. Is that one of our answers there? You betcha. It's letter B, this guy right here. Get rid of this. Let's move on. Super simple one. This won't take any time at all. Thank goodness, because you're probably getting bored with this. What describes this figure? First of all, it's trying to figure out how many sides it has. First of all, you see that it has nothing but sides, doesn't have any curved edges, so we can automatically get rid of J. It is a polygon. Okay? So J's gone. We can get rid of the next one if we just count the sides. 1, 2, 3, 4, 5, and 6. So it's a hexagon. Therefore, G is gone. It's not a pentagon, it's a hexagon. And now there are one or two ways we know that it's not regular. It says right there in both of those answers, it's not regular. Now, is it concave or convex? And this will tell us right here. Do these sides stick inward toward the center of the polygon? Yes, they do. And that is the definition of concave. Right? We already knew those answers, and we said it's concave. Some sides stick inward. Good, let's move on. All right, rectangle. Oh, I love this one. We love this one in class. This was so super simple. And we didn't even have to use the numbers that they give us. If a rectangle has a length of 1.4, all right, I'll use it. 1.4, and a width of 1.2. What is the effect on the perimeter if the length and width are doubled? All right. Well, let's go ahead and talk about this, but let's use easier numbers, right? Wouldn't everybody like to use easier numbers? Let's go ahead and make this 2 and make this 1. It doesn't matter, because all we're doing is trying to figure out what happens to the magnitude of the perimeter, what happens to the size of the perimeter when we double the sides. So if this is 2 and this is 1, this would be 2 and this would be 1. So we just count them up. 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. So perimeter equals 6. Okay, well, let's double our sides. 2 doubled is 4. 1 doubled is 2. And we can just draw the rest of it in because we said we had a rectangle. So 4 plus 2 is 6, plus 4 is 10, plus 2 is 12. Our perimeter is 12. Well, what happened to the size? It just doubled. When we doubled the size, we doubled the perimeter. And we say that perimeter is doubled. What happens if I say, what if the area, what happens to the area? I'll change this to area. What happens to the area? Area is length times width. What happens if I double these lengths and I'm looking for area? Well, the area of this one is 2 times 1, which is 2. And then the area here would be 4 times 2, which is 8. So perimeter is doubled. We got that, and we got that answer. It's right there. It's letter A. But what if I asked you about the area? I'd say, oh, what do I have to multiply 2 by to get 8? Well, you have to multiply by 4. And I'd say quadrupled. You could say multiply by 4. That's totally fine. I would let you get away with that. All right, last one. This is the hardest one of the bunch. Kind of. We needed to know surface area of a cylinder. All right. And we're going to do some estimation here because I don't have a calculator handy. I guess I could get out my phone while I'm doing this. It says Merrick paints a barrel in the shape of a cylinder. To paint 8 square feet of the barrel, he uses 1 quart of paint. The height of the barrel is 4 feet. And the radius of the base is 1/2 foot. If Merrick does not paint the top lid, how much paint does Merrick use to paint the barrel? Here's the fun, right? You need to know surface area of a cylinder, and that would be the area of the 2 bases, but I'm going to get rid of one because I'm not painting one, and that's pi r squared. Area of a circle, pi r squared. Plus the area of the surface area of that cylindrical tube, right? And that's 2 pi r, the circumference, times the height. All right. The height of the barrel is 4 feet, so we can start adding these numbers in, right? Am I in the right? Yeah, that's fine. So the surface area is equal to pi times 1/2 squared plus 2 times pi times 0.5 times the height, which is 4. Okay, so let's do some simple math. 1/2 times 1/2, right, is actually 1/4. So this would be 0.25 pi. For now, I'm going to leave it in terms of pi. I'm going to do this math 2 times a half. 2 halves make a whole, so that's 1 times 4, which is 4 pi. And what I'm going to do is I'm going to put these two things together, then multiply by 3.14. Quarter of a pi and 4 pi's are 4 1/4 pi. And this is just going to give me my surface area. Why do I need to know my surface area? Because I need to then divide by 8 square feet to find out what my paint total would be. 4.25 times 3.14 gives me 13.35 about. So my surface area is about 13.35 square feet. And so if I go ahead and I divide that by 8, that's going to tell me how many quarts I need. So if I go ahead and divide this number here by 8, divide by 8, and what I get is quarts needed is about 1 7/10. Well, I'm going to look up here and say, is this close to 1 7/10? No. Is this close to 1 7/10? Yes. Let's see if there's one that's more, that's closer to that idea, and that would be H. Okay. So this is probably, except for those silly, ugly formulas, this is probably the hardest of the bunch. And then this bonus question is so much fun. Find the measure of A if A is complementary to B and B is supplementary to C. Oh my gosh. And B is 15x minus 2 and C is 25x plus 22. What we need to know is what x is, right? We need to find x first, and then we need to find b, right? Once we find out what b is equal to, then we can find out what a is, because a and b add up to 90. So this is 90, and this is 180. And what I did was I wrote out the formulas here. I wrote out everything out here, right? A plus B equals 90, B plus C equals 180. So my first step is to find x. Find x to find B. Once we find this, we're going to be great. I'm going to transfer this up here since I have room. Actually, no, I'll leave it down here. We'll do this math. 15x plus 25x is what? 40 x's. Minus 2 and plus 22 is plus 20. And that's all going to equal that 180. Right? Well, okay, so let's start doing some of this solving, and I'm going to subtract 20 from both sides. So 40x and 180 minus 20 is 160. We should see the relationship 4 and 16. We're really cool with this now. I'm going to write it over here. 40x, equals 160. I'm already ahead of myself. I'm going to divide by 40 and divide by 40. So x equals 4. Now that I know that x equals 4, I can plug it back into this expression for b. So if b, the measure of b, is equal to 15x minus 2, then, I won't even do that. I don't want to confuse you. So let's go ahead and input that value for the variable. So the measure of b is equal to 15 times 4 minus 2. All right, so the measure of b is equal to 60 minus 2, so the measure of b is equal to 58. All right, so if b is 58 and a plus b is 90, we just start writing it. So the measure of a plus 58 equals 90, because we said they were complementary in the very beginning. All right, so we just subtract 58. And we come up with 32. The measure of angle A is 32 degrees. Sound good? I know, it's a lot. It's a lot. This is a very long, drawn out study video, but I think you're going to do great. Remember to ask me any questions. I'm on Google Classroom. Take care.